Good afternoon everyone. Today I'm going to covering the computer modeling analysis. For this I'm going to use the SAP 2000. Let's get started. First I'm going to open the SAP and I'm using version 20. Okay, let's start from file and new model. First, let's keep in mind unit should be changed at the first, but you can change it during the modeling, but it will be easy for you to choose at the first. And if you want to hear some project information, then write the company name, client name, project name, project number, model name, model description, revision number, frame type, engineer. For me, I'm going to use the company name is Civil Software Academy. Client name will be, let's say, Sangam. Project name will be Sydney Building, and project number will be, let's say, 55, and model name will be, what will be our model name? Residential building, let's say, and model description will be, and you can write the model description as you want, and this will be the revision number. If you like your update, we are going to update the new model, and you can change your revision number, and it will helps to you like identify the which one is updated models. And for the frame type, I'm going to use the steel frame, and the engineer for me Samir, and who is going to check, and name of your supervisor, issue code and design code. I'm going to use the design code, which is 100, which is for the steel code, for steel code. Okay, this is the version information, and you should click the grid only, and this is the default coordinate, which default coordinate, it means like default grid lines 455. I'm not going to use that. I'm just simply click the OK, and this is the default grid. For we have to change this grid into our according to our architecture model, but system and heritage. First we have to, I'm gonna this one, and I'm gonna switch the AutoCAD model, and this one is the roof plan. This is the, let's start from the basement plan. Okay, let's edit. Okay, let's display grid as a spacing, because ordinates makes little bit confusing because these are in spacing basis, that's why. Otherwise it's the same. Okay, in the x direction there is 3 2 1, but as you can see here, these are the columns, and this is in the same grid, but as you can see here, this column and this column are not lies in the same grid. That's why we have to add the another grid line. So for this we have to like check the dimension from here to here, which is 2.207, and we from here to here is 0.545, and it will be 2.9, and rest of all in the y direction are same. Okay, let's get started. And you can see there is a display button, and we can change our grid from here, and we can see what will be changed and what is going to change. You can see over here. Okay, let's ABCD. It means we have to start from 3 2 1, right? And or we are not 3 2 because we add the another grid, it should be 4. Just keep in mind, because we add the another grid. And right, and 4 means, because we start from there, what will be the 4? 2.2.207, and I leave this after the 3 digit 54. It doesn't matter because just only put 3 digit. Okay, let's what will be this distance, because we have the another grid over here, that's why 0.545, and 2 means, which is from here to here, 2.9, 2.9. Yeah, yeah, 1 2 3. Yeah, okay, let's, you can share 4 3 2 1, right? Yeah, because one, we are the one grid over here, because the column this and this not lies in the same grid, that's why. For the y grid, as you can share a b c d, it should be start from a b c d, but here it is 4 3 2 1, it means 4 3 2 1, 4 3 2 1, that's opposite. Okay, let's, 1 will be our, let's start from 4, 4 will be our a, right? B, caps lock, B C D, yeah, and as you can say D C B A, yeah, exactly, yeah. And what will be distance, just from this D, which is 4 meter, and 3.8 meter, 3.8 meter, and what's the be distance, 3.3, 3.3 meter, yeah, this one, yeah, here it is, 1 2 3, yeah, 1 2 3, yeah, that's okay. And for before this, I'm going to check the whether it is correct or not. For this, I'm going to just check the, yeah, you can see 4 3 2 1, yeah, this is great. A B C D, yeah, actually got this one. Now I'm going to edit our elevation, which means our height. Okay, let's edit our grid, and as you can see here, how many levels there is: the basement level, ground floor level, first floor level, second floor level, third floor level, fourth floor level, and roof level, yeah, right? First I'm going to use the grid ID. Basement, percent ordinary spacing, basement level, and this should be 0 because you start from 0. Basement, this, you can simply like change it into level for only basement, and what's your basement spacing, from here to here, which is 2.101, 2.101, which is basement level. And for the ground floor level, which is from here to here, which is 3.3, 3.4, which is nearly round of 3.4, 3.4, and I think others are rest of are similar. 3 point only 3, yeah, exactly. For this I have to add some other grid as well. 3 3 GF, first floor, second floor, third floor, fourth floor, top floor, yeah, exactly, right, yeah. Okay, let's check whether it is okay. As you can see here, this is the basement, this is our ground floor, first floor, third floor, ground floor, first floor, sorry, basement floor, ground floor, first floor, second floor, third floor, roof, ground floor, first floor, basement, ground, first, second, third, roof, yeah. 1 2 3 4 5 6, 1 2 3 4 5 5 6, yeah. This is little bit confusing, but you have to look carefully for the architecture plan. That's why it represents just a level. You can see here, yeah, basement it's by default basement 0, ground floor because basement lies in this level, ground floor, and 17.5, yeah, nice. Okay, okay, we finish up with the grid. Then I'm gonna put the plan over here and 3D over here. It helps me to idealize the model. Okay, we finish up with the grid and I have to save the model. For this I am going to save the model over here. I am going to any folder, save 2000 still design project. File name will be still design project and save. We have to save the model because if we did not save the model and it will miss out. That's why don't forget to save your model while doing the modeling. Okay, now we finish up with the model and we are in the plane G is equal to 0 means we are on the this level, as you can see here, this level. Okay, right, yeah. Did you see the level is changing at the left window, as over here. Okay, let's start from J is equal to 2.101, which is ground floor level. It's the level, ground floor level. Okay, for this I'm going to process by process. Just keep in mind. Okay, first start from define, because we have to first define our material section properties and load patterns, load combinations. Yeah, that's why define, start from material. Okay, I'm working on Australia, that's why I'm using the Australian and New Zealand code. Okay, add a new material. So I'm going to change New Zealand because I'm working on Australia and we are using the New Zealand material code, and that's why. And still type I'm going to still standard, and this is the material code. and grade will be 300 plus 300. We use this grade material, steel grade in Australia. Okay, and I'm going to delete this material because it will confuse me. Yeah, this one is the material, this one is the steel grade material, and add another material, New Zealand. I'm going to use the concrete, this one the concrete, and you see, but there is no 32 MPa. For this I'm going to choose 30 MPa as per our questions. As you can see here, it should be 32 MPa, right? But we don't have 32 MPa. For this I'm going to use 30 MPa. Let's say you can choose for higher. For this I'm going to use 30 MPa because it's 30 MPa when you during the design, when you implement the 32 MPa, if the structure is safe for 30 MPa, and it will automatically save for 32 MPa for this reason. Yeah, okay, and I'm going to save the model and define and finish up with the material. And let's just start from section properties, frame sections. Okay, you can add individually, just like I'm going to use the for column and beam for I section. You can add manually by seeing into the codes, but it will take too much time. For this I'm going to simply select the steel and I'm going to select the Australian New Zealand code. Yeah, this one. Yeah, metal will be 300 plus 300. Don't forget, and don't select the 30 MP because it is the concrete code. 300 plus 300, and these are the I sections, section output. Select all and select all these, and okay, hit the OK button, and these are our section. Okay, I'm going to change the, that doesn't matter. As you can see, these are the frame. Okay, let's frame section. I think I can. Okay, we import our I section. Let's auto select the column. Okay, add a new property, styles. This one will take the individually, but we are going to import for new property I section, and these are the section we already imported through our models. And for this add a new property. For this we have to choose the auto select list. For auto, this one will be the column list. With the software, it will automatically take particular sections for the design. So auto select section is very powerful methods which is available in chef. Okay, for the column, let's universal column add UC UC means universal column. Let's select all the UC. UC. Here is UC 250. UC. Here UC. And UB. I think maximum is 310. Not it should be not 96. It should be 150. Yeah, I think I is finished. But let me check. Oh, sorry, I already column final. Yeah, okay. And there is one another duplicate name, which is I'm gonna delete this one. Oops, I cannot delete this one. Okay, I'm going to delete it last. Okay, I finish up with the column, and I'm going to add the another new property, which is from auto select list. This one for beam, and let's start beam, which is it should be UB. Not UV. Yeah, here is UV. Anything else? Yeah, we have lots of UV. 8. UV, right? I think maximum is 410, but it's still 158. So I think little bit sections are left. Okay. The selection process is to takes some times, but this is the crucial part, because while designing, the programs automatically select preferred sections. That's why we're giving so much time for this, but don't worry about that. If you don't have these options, then we have to select them manually and assign the sections, and there it is, and that will be the too lengthy. And here it is UV. Actually, we don't need that much size for this residential building, but I'm showing you for the process. Okay, yeah. Okay, this for the beam, and I finish up with the column and beam. Oh, okay, don't worry about that. Okay, I finish up with the beam and column, but there should be a bracing. So for bracing I'm going to use the not the angle section, I'm going to use the channel section. So for this I'm going to import the new property for channel, and these are the channel. Okay, let's select all the channels and okay, and hit the, don't forget to see the material. These are the modifier which is not important for this. Get the, and let's add a new property, auto select list, which is for bracing. Okay, hit the OK button. Oh sorry, we have to select our sections, which is PFC. Should be PFC. PFC means parallel flange channel sections. PFC. What are those PFC? Oh, these are start from 75 PFC to 380 PFC. Yeah, 75 to 300. Yeah, these are the PFC. There's no PFC left over here. Okay, hit the OK button, and we finish up with the beam, pressing, and column. Okay, let's save our model. Then we are going to assign our section properties in our grid. Okay, let's get started. Okay, but let me check how many times left. Okay, first we are in ground floor level, so these are the quick frame. Select our straight frame, and first I'm going to add the beam, so select the beam, and here we go. I think we should add the first column, because for this I'm going to exit plane and select this button, not it should be the column final, and here we go. Just simply click for this. Where am I? I'm the DDD. It means I'm in the D. This means it's our column, not this one. Just keep in mind. And we're in the C. C means just this. As you can see here, or you can see for the architectural drawing as well. Here, this one is the D. D means this, not this one. While the B, and the A, for A, don't forget, for A this one is our column. Yeah, and go to plan. Yeah, we are in this level, ground floor level. Okay, let's change column final to our beam. Then for A, don't forget our beam should be like from here to here and here to here, because our column is over here. Look at this. And for this, over here and over here, over here and over here and over here, because I split two beams, because I'll tell you the concept of this. Because if we make the whole beam over here to here, then it will gonna fail in deflection, because I'm gonna put the joist beam over here, and it will finite the beam. So in practical case, and over here, and here it is. For this I'm gonna simply add this one, because it's just a click 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 click. Here it is. Okay, for this, as you can see here, this one is our column. This column to this column, I'm gonna use the main beam. Okay, from here to here, this will be our main beam, and our column is here, and from here to here, this will be our main beam, right? And for this, I can also use the from main over to here main beam, and rest of all the space I will cover with the joist beam. Don't worry about that. Okay, let's save the model. For joist beam, I have to select the joist beam as well, but for the modeling purpose, for easy purpose, I'm going to define the another joist beam sections, frame section, just for the beam. Add a copy of property, add this one, but I'm gonna do the beam, add a copy. Oh, I thought it's I can select. Okay, don't worry, let's joist beam. Okay, let's switch from auto select. Oh, so I cannot, I think I can select from there. Just add a new property, auto select list. These are the, and I can select UV, and UV, and here you go. I think 310 UV is not required, but let's choose, because joist beam is smaller than the main beam, but that's alright. I'm gonna choose all the beams. Just let you know, the program will automatically choose the desired sections. Yeah, 10 is maximum. Yeah, okay. Where's the joist beam? Oh, this one will be the joist beam. Yeah, joist beam. This one will be our joist beam. Okay, yeah, okay. Okay, for joist beam, I'm going to add into the, I'm going to make the spacing will be 1 meter, so it will be easy for to assigning the loads for the 1 meter spacing. So I'm gonna put that in number of beam. So this will be our joist beam. So number 3, but the spacing will be our spacing is, no, I think it's not okay, because number of beam, spacing, number of spacing, so spacing will be 1 meter. it will automatically generate. As you can see here, I think this part is our staircase part, that's why. But yeah, here we go. Yeah, here we go. Don't forget to save the model, and if you want to see an extrude view, then go to over here, go to this button, set the display options, and general option, go to extrude view. I'm gonna first apply this model, and here you go. Is it extrude view? Here we go. I can feel over this one with the staircase. As you can see here, this is the eye section. Okay. Captured, because if I left this in extrude view, it will take more RAM. It's gonna be freeze. So this one is our basement. This one is our for basement. For the first floor, the column size, the height of the column is different, so I'm going to just only copy the beams, not the columns. So for this, I'm going to exit plan and select all the columns. I think it's better go to 3D view over here, and like this I'm going to select all the beams, not the column. I'll select the beam. See, yeah, I'm gonna need that beam from here to here. Okay, it means I can replicate. Control R means replicate by control and R. If you press the control with first control and then R, then these are the radial, these are the mirror, this is linear, and with increment 1 2 3 4 5, it should be 5 increments. And sorry, first put the one. I'm going to tell you why. Pick 2 points. Otherwise you can just put over here. This is still with the, what will be the, this one, these are, as you can see here, X, Y, Z. Z will be, what will be your Z? What will be this side? What's the this side? If you see the drawing, this 3.3, right? 3.4, not 3.3. 3.4. As you press the apply button, I think this one will freeze. Here you can see over here, this one at the, don't know, another window. This one will be our 3D and this one will be our plan. This one, here it is 5.5, yeah, 5.501. there, it is okay. Yeah, let me check whether it is could be, yeah, let's check again. 3.4, yeah, right, yeah, okay, 3.4. And I'm gonna make the column over here for column this one, and for column, which are column final, here you go to the exit plan and just replicate just like this, just like this. Yeah, finish up with the column and don't forget to save. Here you go. Do you know why I did not replicate all this beam throughout the over? Because from here the column, the height of the column is same. That's why I'm gonna select all the column and beams and replicate to the up to the top floor. That's why for now I'm going to get the similar process like this, and let me check whether all beams are selected or not. Yeah, all beams are selected. And for now, Control R, replicate. This time not 3.4. This time how many? Let me open the drawing. This time 3 meter, right? Yeah, 3 meter, and number of will be 1 meter. 1 2 3 4 1 2 3 4 1 2 3 4. Let's not only 1 4 just. Okay, we make the column up to the ground floor, and let's go to the first floor, and this one for plan. Okay, and good. And for exit, now we have to make the column final over here, over here, over here, over here. Over here and over here, over here. Yeah, okay, save. And over here, no, I'm gonna choose this one, this one, this one, and this one, this one, this one, this one, this one, and this one, and this one, and this one. Yeah, and this one as well. This one as well. I have to make sure all the columns are should be select. Control R, it should be 1 2 3, it should be 3, and R should be 3. Here we go. Now the plan, if I go to the top floor, this one will be a top floor. Actually I don't require the others beam because it should be only the staircase cover, so I'm gonna delete this, just only this here. So I have to select the another beam. not a column final, should be beam here to here, right? Yeah. Okay, let me check. Or I have to use the column over here, not column final, and here you go. Let's final. Let's check whether our column is. I have to delete the individual column as well. Yeah, right. Okay, this one too as well. For this I have to add one column here to here. Okay, let's check whether our model is correct or not, because X-ray view helps to analyze the model, not only this. And section are different. Here you go. For this I'm going to turn off this one. Okay, here you go. You see, red are the joist beam, and this color will be the main beam, and blue color is the column. For this I have to put the joist beam over here as well. For go to the X and go to top. This one is top. So for this will be like this. No, should be parallel to this shutter span, not to Y, should be an X, because shutter span will be critical. That's why. Yeah, as you can see here. Also I'm gonna change this one. This one is okay, but for this one I'm gonna change into shutter direction, so I'm gonna delete that one. So what let me check. So actually I did a mistake over here, and I realize, yeah, not the column final, it should be our joist beam. Don't forget that. This one, right? This one, this one, this one, and here you go. I'll do for it, don't worry. Okay, over here, because just grid, it extends just only for the grid. For this I'm gonna add the joist beam from here to here, and here to here, here to here, and I'm gonna delete. First I have to delete this beam, because otherwise it will be error. Or I have to go to the file, or go to the view, define, edit, and there should be the oh sorry, there should be the define or draw. Yeah, it's in okay, now I'm going to extend this one. So perpendicular, as you see. I need to change this one perpendicular. Go to draw and select the snap to perpendicular projections. Here we go. Draw, snap to perpendicular projections, just like a snap. And here we go. This one is fine. And for this, go to this one and this one. Let me try first. Yeah, here we go. This one from here to here, from here to here. Is that the joystick beam? Yeah, here we go. There's only one. Yeah, and see the rest of all. These are the correct. I'm gonna delete all of these. Yeah, this is our final. Just select this, all the joystick pin, and go to 3D view. This should be in top, right? Okay, then Control R. It should be in -3. How many times? 1 2 3, right? Yeah, 3. And previous selection will be and will be -9, number 1. Where did it go? Let me see first. Yeah, here it is. Here it is, -9. And for this, go to the plan and go to this plan. Simply click all the twist beam, then make it to 3D. Then what should be its height? How many this height? This height will be the from here to like 3.4, right? Yeah, -3.4. Increment only 1. Yeah, okay. It's our model. But before that, let me check whether we meet our architecture plan or not, because we have to meet our architecture plan as well. As you can see here, this is our basement floor. As you can see here, there is a space, not a room, patio. So I'm gonna delete all the floor which lies in this area. So go to the plan and this one is basement, right? we need the basement, but from here I don't need any beams and column over here. Just keep in mind we have to make the same edge architecture drawing and go to 3D model and check it, and don't forget to delete the column. Here you go. Yeah, to see this is our model, and I'm going to add the staircase and the landing beams for the next sessions, because it will take too much time, because I don't want to make the video long for this time. It's already 1 hour, so I will add the staircase and landing beam for the next session, but for this session I'm going to make the base fixed. So select all the base, so assign joint restraint. So for this you have to think carefully whether it is fixed or like this, fixed or hinge. You have to make sure. For this, generally the steel structures are not fixed because we put the base plate at the base, so base plates normally acts as a hinge, not a fixed, because as you know, when our RCC building is designed, then we use the fixed base connection because we put our footings and into some certain height below the ground. That's why we use fixed, but in steel we use the hinge for the base plate connection. So don't forget this concept, but I will explain about this concept as well for later lectures. So for this I'm just only click there and apply, and don't forget to save and see. When I finish up the model, then I'm going to define the load patterns, load combinations, and I'm also here the joint, just these are the joint patterns define. Yeah, let's see the project information. I think we just create the 3D model in a SAP, apply all the determined loads, and this will become next. And okay, this is for today, and after this lecture I'm going to finish up the model, and first I'm going to add the staircase, and I'm going to assign all the loads, and I'm going to show you how the load is generated from the codes, and not only the tail load, live load, I also help you to generate how to generate the like wing load as well. Not only the value, I will show you how to calculate manually wing load. That's why just keep in those lectures. For the upcoming lectures, don't forget to subscribe my channels. It will really help me to motivate for the next lectures. Thank you so much for your support. Thank you. Bye bye.